Hello and welcome to this video covering Dell Storage SC Series live volume with automatic failover. In this video we'll cover a live volume overview. We'll take a look at the live volume features introduced and available in Storage Center 6.5 and 6.6, and then we'll focus on live volume automatic failover and repair, which is a new feature introduced in Storage Center 6.7. We'll break away for a lab demo, and then we'll wrap it up with some frequently asked failure scenarios around automatic failover. So what is live volume? If you think about data progression, which migrates data within a storage center between tiers of storage and RAID levels, live volume is very similar, except that it migrates data between storage center. In addition, it has the ability to present that data, the same set of data on both storage centers, to a storage host or a cluster of hosts. This architecture can be beneficial for serving both proactive and reactive business use cases. Live volume in Storage Center 6.5 and 6.6 introduced some key features that were built around synchronous replication. Support for both high availability and high consistency synchronous replication was added to live volume in Storage Center, as well as the ability to migrate replication types. For instance, you could migrate from asynchronous to synchronous HA, or synchronous HA to synchronous HC mode, or from synchronous HC mode back to asynchronous mode without having to tear down and rebuild the replication or reseed the data. Live volume managed replication was also added to Storage Center 6.5, allowing you to replicate live volume data to a third storage center. Typically, that's going to be off-site, perhaps at a DR site for disaster recovery. Preserve live volume was a feature that was added in Storage Center 6.5, which allows the recovery of a live volume in the event of an unplanned outage. These features combine to allow customers to build stretched compute and storage clusters between sites for a variety of proactive use cases. Storage Center 6.7 introduces automatic failover for synchronous live volume, which provides both high availability and disaster recovery for applications and services. In the event of an unplanned outage impacting a live volume on a particular storage center or at a site, the live volume will be automatically failed over and recovered within a matter of seconds on the surviving storage center to provide continuous uptime for applications and services. No administrator or user intervention is required for the automatic failover. The architecture of live volume with automatic failover includes two highly available and redundant storage center arrays. Each are capable of providing 5 nines uptime and 0 RPO and RTO. A new quorum witness is introduced in this architecture, which is built into Dell Enterprise Manager and deployed at a third site. This quorum witness or tiebreaker service requires 200 milliseconds or less latency between it and each of the sites containing a storage center. At the time of a release, automatic failover for live volume is supported only between the same family of SC Series controllers, in other words, SC8000 to SC8000 or SC4020 to 4020 or perhaps SC9000 to 9000. Live volume with automatic failover in Storage Center 6.7 is limited to VMware vSphere environments and is certified with VMware's Metro Storage Cluster or VMSC certification. Last but not least, live volume with automatic failover is compatible with the live volume managed replication feature. If automatic failover occurs, live volume managed replication will follow the primary live volume to its new storage center source. There are a few requirements which must be met for live volume automatic failover and vSphere Metro Storage Cluster. Storage Center 6.7, Enterprise Manager 2015 R2, Fiber Channel or iSCSI synchronous high availability replication between storage centers, a minimum of 250 megabits per second on the vMotion network between vSphere hosts. The round-trip latency on the replication network must not exceed 10 milliseconds. This was called out in the previous slide. The connectivity to the tiebreaker service at the third site must not exceed 200 milliseconds of round-trip latency. Live volume automatic failover in Storage Center 6.7 is supported on vSphere 5.5 or 6.0, and it's supported with VMFS data stores only. There is no support for physical mode RDMs. The vSphere cluster must be configured for HA or high availability to handle both PDL and APD events, whether this is vSphere 5.5 or 6.x. This HA configuration is covered in the Live Volume Best Practices Guide available from Dell Storage. Last but not least, Live Volume with Automatic Failover supports either uniform or non-uniform storage presentation in the vSphere Metro Storage Cluster configuration. So let's take a closer look at non-uniform and uniform storage presentations and how applications and services will be impacted by unplanned outages at a site. In this scenario, we have an unplanned outage in Data Center A, which takes out the vSphere hosts as well as the storage in Data Center A. Storage Center B establishes quorum and triggers the promotion of the secondary live volume to the primary live volume in Data Center B. After this automatic failover has occurred of the primary live volume, the virtual machines can resume in Data Center B. However, the virtual machines in Data Center A are still offline due to the unplanned outage. When this occurs, HA, when properly configured, will automatically restart the virtual machines in the surviving data center, and those applications and services will once again resume. When the infrastructure at Data Center A is brought back online, Storage Center will prevent a split brain condition by preventing access to the volume on Storage Center A. Storage Center will then automatically repair the live volume on Storage Center A, and once that volume is repaired and the replication of the changed data occurs, that volume will become the secondary live volume and will once again become accessible for the vSphere hosts in Data Center A. The automatic recovery feature has now protected the live volume between both sites should another unplanned event occur. Now let's take a look at a stretch cluster with a uniform configuration. In this storage presentation model, each of the vSphere hosts in the cluster is zoned and mapped to each of the live volumes on each of the storage centers. This presents somewhat of a mesh topology of storage presentation. Once again, we have a disaster which strikes Data Center A, which impacts the virtual machines, the vSphere hosts, and the storage running at Site A. Similar to our previous scenario, Storage Center B contacts the tiebreaker running on Enterprise Manager at the third site and triggers the promotion of the secondary live volume to the primary live volume on Storage Center B in Data Center B. Once the primary live volume is automatically failed over in Data Center B, the virtual machines that are still running at Data Center B will continue to have read-write access to the live volume. vSphere HA will migrate virtual machines that were impacted in Data Center A to Data Center B. Those virtual machines will be powered on by vSphere and will have readable, writable access to the live volume in Data Center B. Site A is brought back online, and once again, Storage Center will prevent a split brain scenario as it automatically recovers the live volume and re-replicates the data back to Storage Center A. Once that data is replicated, the live volume at Storage Center A becomes a secondary live volume and is available for the stretch cluster. Alright, now let's jump into a live lab demo and showcase live volume with automatic failover in a vSphere Metro storage cluster configuration. This is my stretch vSphere cluster containing 2 hosts and a number of virtual machines. If we take a look at the data stores, I've already got a Tier 1 data store which is already configured for live volume. If we go back into Enterprise Manager, we can take a look at this Tier 1 data store, and we can see that it is indeed configured for live volume. However, we have not configured automatic failover, so let's go ahead and do that. We simply right-click on the live volume, choose Edit Settings. Notice that we're meeting the requirements of synchronous high availability replication, and to enable automatic failover, we simply tick the box at the bottom labeled Failover Automatically. We've also got the Restore Automatically feature, which is automatically enabled by default when we enable failover automatically. So if we have an automatic failover occur and then we recover the site with the unplanned outage, the live volume will automatically repair itself, which I talked about in the previous slides. So I'll click OK, and at this point, in just a few moments, live volume with automatic failover should be configured. I'll go ahead and refresh the window there, and we can see now if I slide over to the right for this live volume that we are protected. We are configured to fail over automatically. We are also 100% complete on our synchronous replication with 0 megabytes remaining. This is my virtual machine that we'll be taking a look at to monitor the impacts of the outage as well as the automatic failover of live volume. In this virtual machine, we're running the iometer application, which will help us understand the I/O patterns that are occurring while the outage occurs and while the automatic failover recovers the live volume. We'll also use this stopwatch application to monitor the timing of the events. This is a uniform storage presentation, by the way, so if we take a look at the presentation of the live volumes to our stretch vSphere cluster, if we look at the first storage center, here's our tier 1 data store, we can see that the mappings for the primary live volume are presented to both ESX1 and ESX2. Likewise, if we go to our second storage center and look at the secondary live volume mappings, once again, these mappings are presented to both ESX1 and ESX2. So this is a uniform storage presentation. And so what that means is that when we perform the unplanned outage of our storage center, and I think I'm going to go ahead and perform that outage on the first one here just for simplicity's sake, what we should see happen is that the I/O for our virtual machine, which is running on storage center 1, where the primary live volume is, that I/O will briefly pause. The virtual machine will stay running. Storage center will automatically fill over the volume, and then the read-write access to the live volume will resume once that live volume is automatically recovered on my second storage center here. So let's go ahead and power down that storage center. We'll cause an unplanned outage of the storage that's supporting this iometer application in my marketing virtual machine. I'm going to slide my web browser over here where I've got BMC access to the storage center, both controllers, and we'll go ahead and what we'll do is we'll power down those storage center controllers, and immediately after I will start the stopwatch application, and we'll take a look at, we'll have to watch iometer as well as the stopwatch to see the events that occur. So we'll reset controller 1 and reset controller 2. And as soon as we see there the I/O is stopped, we'll start the stopwatch. So at this point, both controllers are down. Effectively, the first storage center is down, and we can see that at this time, the read and write I/O for our iometer application has paused. At this point, the automatic failover should be occurring within storage center. The recovering storage center is contacting the tiebreaker service on Enterprise Manager, and in just a moment or two, our I/O should continue. And I can see that our I/O has recovered. It took about 30 to 35 seconds for that to occur, and now our application is once again has read-write access to that live volume. So this was not an HA restart. Again, this is a uniform configuration where we didn't lose access, or we didn't lose our vSphere host. We only lost the storage in the storage center that was backing our application. So live volume with automatic failover was able to recover the primary live volume, and our application's read and write I/O was able to resume. If we go back over to our vSphere client, we can see that the tier 1 data store, which is configured for live volume with automatic failover, that data store is still available. In fact, I can click the refresh button here, And we see that that data store is still available, and there's our marketing virtual machine running the iometer application. Looking at Enterprise Manager at the state of our live volume, we can see that we've got some red indicators. Those are a result of powering off the storage center. But if I slide over here, we're looking at the live volume of our Tier 1 data store. What we can see is that that data store, or that volume, is still up now on the secondary system, or it's up as the secondary live volume. We slide over even further, we can see that the failover state indicates that we have automatically failed over. Okay, it's been a few minutes now. Our storage centers in Site 1 have been rebooted, and they're actually back up. We can see that the front-end ports are unbalanced right now. I'll go ahead and balance those a little bit later after I'm done recording the video. But let's go ahead and check the status of the live volume once again. And we'll click refresh here. We can see now that quite a bit of the redness has gone away in the live volume status. In fact, if we take a look at our Tier 1 data store, we can see that both the primary and the secondary live volumes are up once again. Replication is 100% complete. And probably the most important thing to point out here is that the failover state is once again in the protected state. So this is an indicator that our automatic recovery or recovery automatically feature portion of live volume has executed its task, and we are once again poised in protected mode for some other unplanned event should it occur in the future. So those are two very key features of live volume in Storage Center 6.7, automatic failover as well as automatic recovery. If we go back to our virtual machine, we can see that our applications, iometer in this case, are still running, still have read-write access to the live volume. That did not stop at any point during the automatic recovery process. With the lab portion complete, we'll wrap up this video covering some commonly asked about failure scenarios. So the scenarios we'll talk about are primary array failure, secondary array failure, network partitioning, back-end failure of the storage center, as well as outages to Enterprise Manager at the third site. So primary array failure I showcased in the lab demo. What happens if the primary live volume or the storage center supporting the primary live volume goes down? As we just witnessed, the applications and services will resume running because automatic failover to the secondary occurs in this case. What happens if we have a failure of the secondary live volume or the array that's supporting the secondary live volume? In this case, there is no automatic failover because automatic failover doesn't need to occur. The primary live volume is still available at the surviving site with the surviving storage center, and the read and write I/O can continue from that primary live volume. No auto failover is required in that scenario. If a network partition occurs impacting the replication network between storage centers or between sites, no automatic failover will occur. The secondary live volume will go offline. The primary live volume will continue to service the read and write I/O. So what if there's a failure on the array on the back end which impacts the availability of volumes? The most common thing to think about, or easiest thing to think about, might be the loss of an entire disk shelf or the loss of several disks within a disk shelf or across disk shelves. What happens? In this case, automatic failover will occur. The secondary live volume on the surviving storage center or the surviving hardware on the storage center, that live volume will become the primary live volume, and I/O will continue to be served through Storage Center B as well as through Storage Center A across the replication network. The last two scenarios involve an outage of the Enterprise Manager or network connectivity to the Enterprise Manager. The outcome is going to be the same for each of those. In the event that either storage center cannot communicate with the Enterprise Manager tiebreaker service at the third site, automatic failover is not possible and it will not occur. However, we can still invoke manual failover through some other enterprise manager at any of the sites. In the event that there's a network link failure between the storage centers and the enterprise manager tiebreaker service at the third site, the outcome is the same as the previous slide. Automatic failover is not possible and it will not occur. However, manual failover is still an option. Note that in both of these last two events, there is no outage of I/O on the storage centers themselves. So storage centers, both the primary and the secondary live volumes, will continue to serve read/write-O. The enterprise manager tiebreaker service is unavailable to provide automatic failover should we lose network connectivity to the tiebreaker service or should the enterprise manager tiebreaker service go down. So that concludes this video on synchronous live volume with automatic failover. Thank you for watching, and for more information, please visit Dell Tech Center.